Here's a video on lesson 71, solving exponential equations. Now I want to start off with a little bit of notes so that we have all this info moving forward. We're talking about exponential growth and decay. It was just an intro to the two formulas, so compounding and continuously compounding. Those will be covered more in lessons 72 and 73, so don't really worry about them. This is just in case you want the full notes. What we're really solving is we're solving Regents examples of questions with provided equations. So I'm going to pull one of these two-part questions that we did for homework. Question number 8, for instance. We're going to use number 8. The current population of Little Pond, New York is 20,000. The population is decreasing as represented by the formula P equals A times 1.3 raised to the negative 0.234t, where P equals the final population, T equals the time in years, and A equals the initial population. So there are a couple questions here. To the nearest 100 people, what will the population be 3 years from now? That's the first question. So let's handle this one piece at a time. The current population is 20,000. 3 years from now, the population will be different. So clearly, if I'm annotating this equation, 20,000 is my starting population. Because I really only have a couple options. They tell me what these letters mean. They tell me that P is equal to the final population and A is equal to the initial population. By final population, they mean the population that you end off with. So I'll say it's the ending population. This, they say that A is our initial population. Initial also means starting. So this is our starting population. And T is time. In this case, they're talking about years. So here's what we have. 20,000 is my starting population. That is the case. They gave me that. Now I have three variables. I've got P, I've got A, and I've got T. Well, we already know what A is. For part A, question part A, they say to the nearest 100 people, what will the population be 3 years from now? So they give me this bit of info. Is 3 going to be the ending population, or is it going to be the time in years? I think that's pretty obvious. They're telling me that T is 3. So I'm just going to write this here because I'm going to pull it over to my loose leaf anyway. Just want to mess with the pen here. Okay. So they're telling me that they want the ending population when the starting population is 20,000. I'm just plugging into this equation up here, by the way, times 1.3 raised to the negative 0.234t. But they tell me t. They tell me that the time is 3 years. So this is going to be times 3. And I'll put that in parentheses. This is really easy to solve at this point. This is nothing but a calculator job. I'll pull this over to my loose leaf just because I want some more room. This is for 8A. So we plug this in here. 20,000 times 1.3 raised to the negative 0.234 times 3. I can do this all at once in my calculator if I want to. Let's see if I can remember all those numbers. 20,000 times 1.3 raised to the negative 0.234 times 3. And we hit enter. 16,635.726. 16,636. Because you can't have part of a person. So the population is 16,636. It's always a good idea before I give a final answer to check the question to see if they asked me to round. Yes, they said to the nearest 100. So they don't want the tens or the single people. They want us to round to the nearest 100, which would be this. I did put the right. 1.3 raised to the negative 0.234 times 3. Okay, cool. So we're going to round here at the 6, so we'll get rid of these guys, and my final answer will be 16,600 people. Okay, now for part 8b, I'm going to start with the same equation. My final population is equal to my initial population, which is still 20,000, times 1.3 raised to the negative 0.234 t. So what I need to do is I need to see what they want for part B. They say to the nearest tenth of a year. Okay, so they want me to find t. That's clear. How many years will it take? I was right, they want t. How many years will it take for the population to reach half the present population? To reach half the present population. So what is the present population? The present population is 20,000. What would half of that be? They want P to be equal to 10,000. The population is decreasing and they want to know how long will it take before it's half. So we'll plug this in. And t is going to stay a variable because that's what we're trying to solve for. Now, if you've been paying attention the last few days, you know that in order to solve for one of these exponents, we need to do a couple things. We need to isolate the exponential term. So I isolate the exponential term. Well, this is the exponential term here. It's the only thing that has an exponent on it. So in order to get it by itself, I'm going to have to divide both sides by 20,000. Those cross out. I get 0.5 on the left is equal to 1.3 to the negative 0.234 t power. Now it's isolated, so I would like to get this to come down, and in order to do that, I need to log both sides. Once I log both sides, I'm allowed to bring it down, so this side stays the same. Log of 0.5 is equal to negative 0.234 t times log of 1.3. Now t's right here. It's almost within sight. All I have to do, divide off the things that I don't want. So divide off log of 1.3. And that'll cross this out. The left-hand side of the equal sign, I'm going to do that in the calculator. Log of 0.5 divided by log of 1.3. And I get negative 2.642. We have 2.642. And that's equal to negative 0.234 t. My very last move, to get t by itself, I'm going to have to get rid of this coefficient by dividing it off. Negative 0.234. I'll cross this out. And I have to do it on the left as well. So those are gone. And t is equal to, let's see if I can remember this number enough to put into the calculator. Negative 2.642 divided by, or rather, log Oh, no, I got rid of the logs last step. Forgetting remembering the... Okay. Negative 2.642 divided by negative 0.234. And I get 11.29, which I might want to round to 11.3. 11.291. And let's see how they wanted me to round it. They said to the nearest tenth of a year, so I can keep one decimal place. So I'm going to want to pay attention to those directions in order to get full credit. I'm going to get 11.3 years. Okay, you can feel free to rewatch that for my methodology if you're having any issues with this. Okay, or feel free to ask me any questions about the question or about the video when you see me in class.